everyone. Good morning, good afternoon, good evening from wherever you're joining from. Uh, Welcome to the launch event of global launch of the Buildings AI, the Agentic AI platform for load calculation and building energy modeling. Today we have a lot of introductions, walkthroughs, and workflow walkthroughs. So stay tuned. So with me, I'll start with introducing the speakers. So we have Sandeep Jadhav. Sandeep Jadhav is the CEO of CCTech. He's a MTech aerospace engineer from IIT Bombay. So he has led a lot of product development teams. His area of expertise is CAD and CAE, and he has led a lot of product development teams in and launched a lot of developed a lot of products in the area of CAD, simulation, and CAE. So 3D printing, it includes a lot. So welcome, Sandeep. And then with
Thank you, Praveen. Good to connect with everyone joining all across the globe. We look forward to take you through our product introduction session.
Yes.
I think we can do a quick introduction directly. Ian, would you like to?
Sure, yeah, thanks, Sandeep. Hi, everybody. My name is Ian Malloy. I'm a Director of Product Management at Autodesk in the Building Group, and I look after everything MEP, design through fabrication, but then also everything to do with our energy and carbon analysis tools and platform.
Right. Thank you, Ian. Rohit?
Rohit.
Hello, everyone. I hope my voice is clear. My name is Rohit. I am a business head here at simulationHub team, and I'm really excited to commercially launch this Buildings AI and interested to understand your problem and how we can solve it using Agentic AI platform. Thank you.
Great. Yeah. So thanks.
I mean, your video is off while we go to next slide.
Yeah.
Can we go to?
So these are things we will cover today. So we'll start with some context, setting the context, a building performance simulation, and then we'll have a short look back at the journey so far, how we reached here, and then buildings a overview, benefits and capabilities, and the main load and energy workflows, and what's next from here. So we'll hear directly from the minds behind this Buildings AI platform. Sandeep?
Yeah. So thanks, Praveen. And I'm fortunate to have Ian with me, who has been part of this industry for now almost 30 years. And I think we have been seeing the BIM getting adopted across the globe. And Autodesk has definitely played a key role, and Revit's platform especially has made sure that now a lot of us are using BIM in our life in managing our building projects. And as that happens, it's also needed that we use in physics-based simulations to validate our design. Can you go to next slide? So we see that with the energy crisis in 1970s, actually committees were formed, and they try to make sure that the buildings utilize a minimum amount of energy, and then the standards got evolved. And I think Ian, I would like to add something more here, how this building energy modeling space has evolved over the 4 to 5 decades, right, Ian?
Yeah, I mean, I'm just going to speak about this and BIM in general. Like you could argue BIM has been around a long time, but historically the majority of that use has been around coordination and documentation. But it is growing in that area alone, but also we're seeing it grow increasingly for use earlier on in the process, and for particularly to feed analysis workflows or to connect to analysis workflows. So things like energy analysis, load calculations, code compliance, and things like that. And so that's evolving in parallel to the domain itself, which is changing rapidly. But the emergence of a lot of open source tools and data and a lot of technology now is really starting to rapidly change the way in which a lot of these problems can be solved. So it's an exciting time to be involved in this, even after nearly 30 years involved in the space.
Right. Yeah, I think this has really changed the way now we manage the energies and the HVAC system. How do we size them? And there is a lot of maturity that has come in the way, but still we do see that not everyone is using them, right? There are two paths. There is a performance and prescriptive path, and there are a lot of still sticking to prescriptive path. Ian, what do you think? What is the reason that it is still there are number of users still following a prescriptive as compared to performance?
Well, a lot of people know here that this work is very complicated. It requires a lot of expertise, and there's a lot of different tools for people to pick from. There's a lot of different goals that people can have, a lot of different standards that they can work to. And so, it's one niche within a bigger industry, but it's a very complex one. And that not just the domain, but the tools and workflows have always been, required a lot of expertise to navigate, to get started. And that's kind of what's exciting about the sort of new generation of tools that you guys are producing, is that you greatly lower that barrier to get, further into that process. Is what's going to changing. But in a lot of that time, fundamentally, a lot of these tools and workflows haven't really changed that much. There hasn't been a radical shift in the way things work. It's been a lot of incremental improvements in different areas.
Sure. I think can go to next slide, Praveen. So we will see that although these tools are there, and there is a now ASHRAE guidelines of how do you use this tools in various life cycle of buildings, right? So you can start using from conceptual to a post occupancy, and there is a lot of interventions that can be done which can make building really comfortable for the occupant and also to the neighborhood, right? Yeah.
That's right.
So I think these are the stages, and that we see that many of the time they use it only as build stage, where finally they just try to get a uh, get a report to get a building code compliance. But there is a lot of value if we start to use it from early on at every stage. And Revit system analysis has been doing a really fantastic work where you can use that at different stages, and we'll see that with a couple of slides from Ian. Ian, would you like to introduce?
Yeah, thanks, Adeep. So first of all, I just wanted to say thank you to the Buildings AI team for actually inviting me to speak here. Next, I wanted to say it's, I've said this already, but I'm really excited about the work that you guys are doing. It's a testament to your expertise in both domains of building energy and systems analysis, and also some of these new technologies that we can take advantage of. But if I may also say, it's also a testament to building on a platform and the use of open source components and data. And I just wanted to just provide a little level set, just so that everybody understood that a lot of what the Buildings AI team have done has been built on top of a lot of the work that Autodesk has done on its platform. So the next slide, Praveen, if you go to it, just provides an overview of the tools that are available to you, both in Revit and on our Autodesk Platforms Cloud Services platform, that you can use to do this type of analyses. I will say in a more traditional sense, where you build a model, you run the analysis, and it's more manual. It's again similar to what everyone's been doing for the last 30 years, and you'll see what the Buildings AI team have done in a minute. But there's really fundamentally 4 parts to it. The first is Revit itself, Revit, and taking a Revit architecture model, which can come in a variety of forms, from something very conceptual to something very, very detailed. It's possible to create what we call the energy analytical model from that. There's a number of different workflows to get there, but you can create what is ultimately a GBXML, so following the open standard. An open schema to do that. You can create an analytical model in Revit, which can then feed into two main features or products. They're really both a part of Revit, but we just give them different names to sort of identify them separately. The first one is Autodesk Insight, which is a cloud-based service for essentially doing total carbon analysis. So that's both embodied carbon analysis as well as operational carbon analysis. And we really like to stress here that it really provides you a starting point for carbon analysis, because it's impossible to do a complete carbon analysis when you don't necessarily start with a complete model. An architecture model is not a complete model. It doesn't contain things necessarily like the foundations or the ducts or pipes or things like that to do a full carbon analysis. But what it does do is it takes all the architectural elements, it takes the GBXML and uses that to do an initial embodied carbon analysis using data from EC3 as a starting point. And then it does a whole building energy simulation using Energy Plus and Open Studio, presents that information in a dashboard, which you can then customize. So not only can you customize and refine the data that goes into the Revit model, you can also add anything that's missing there. So for example, if you want some rules of thumb for the foundations or the MEP, you can add that into the Insight dashboard to create a full picture, and you can see some sort of real-time cause and effect by understanding that. So Insight's kind of role is not just from that early stage, but also later throughout the process, and really helping keep track of the overall aggregation of total carbon and the major kind of drivers of that. And like I mentioned, that runs in the cloud. It uses Energy Plus and Open Studio, which is really the open components that are shared with the feature that we call Revit Systems Analysis, and that runs on the desktop. And what that basically does is, out of the box, it provides a kind of vanilla HVAC loads analysis or an annual building energy simulation. But because it's powered by Energy Plus and Open Studio, you can create customize Revit, you can customize Open Studio measures to meet different needs. So you can do more advanced things to do with either pulling information from equipment or driving information to equipment in the Revit model. And you can also start to do some things around code compliance and so on. So really between those sort of two main sort of product lines, Insight is kind of more the easy button and the more visual interactive feedback you get from this type of analysis. Systems analysis is more raw under the hood, and because it runs on the desktop, and all those Energy Plus files and Open Studio files are all created so that you can really do some quite advanced customization, and that's the thing that the Buildings AI team have really leveraged. And then finally, the fourth thing is all of that all runs and in some form or other is available as part of Autodesk Platform Services, so that if you want to interact with the model, and you'll see how the Buildings AI team are doing that, or you want to interact with any of the data or services, there's various Autodesk Platform Services for running those analyses and accessing that data. So that's it for me. Thanks very much for just the time to explain that. You're going to see some really exciting things now for what the Buildings AI team have done with this.
Thank you. So I think as in science, it is said that you stand on the shoulder of giants and build a bigger things. So it's the same thing that, the Revit system analysis has really done a lot of foundational work in solving complex problems. And what we are doing at a Building AI is first is democratizing it. So we are taking it on a cloud-based application, a web browser-based application, where you can use all that functionality through our application. It also provides a lot of extended functionalities in terms of the number of inputs that you can process, the way you interact using a simple agents like simple English language, and start to build some of those things. And you will also see how we also leverage this data to build a digital twin, connect it to Tandem, and then also take it to a digital handover. So we are doing this, taking system analysis on a very bigger level and extending and expanding on a broader canvas. So if you go to a next slide, Praveen. So whenever I talk to a professional in this field, that they always say, there are still a lot of buildings that are getting constructed without actually being simulated in terms of different type of physics-based simulations. And that's kind of disturbing, that why we are not using them. And when we started to investigate this further, we saw a lot of challenges for the industry. There are users who may not have access to a certain software. They do not have a understanding of the workflows. They do not have a in-depth understanding of physics. So we try to decide this, simplify this task, and make sure that we take it to a broad range of industry. And with this vision, we started conceptualizing Building AI, where we said, like, let's try to build an application which basically helps to build a sustainable build environment, where we use a lot of intelligent technologies and help the user to remove these blocks and actually use that at a very early stage. because if we start to use this thing, they will see the benefit, and we will start to the everyone, the occupant, the building owners, and the government, everyone will be happy in the in this ecosystem of buildings. So with this thing we started our journey. And if you go to next slide, Praveen. So this is the interesting thing that we started. We have a offsite, and we went to a place, and we were discussing, oh, okay, we have a product for thermal comfort analysis. We are doing a high level of CFD, but still it is not being that much used. And the bigger problem in building industry, we realize that they want to get a accurate load calculation, energy simulations, and they also need a very close connected ecosystem. They need a digital thread, starting from, let's say you have AutoCAD architecture drawing. How can I generate the outcome? I have a PDF file. How do I do that? If you have a Revit, then definitely Revit system analysis is one of the good alternative. And so we did this. We sat through, and then we kind of uh, figure out the certain solutions, certain ways to solve this. And this was much beyond even Agentic AI and things were taking it. We were just decided that we will use AI as one of the enabler in this. Although the physics engine will be the foundation for that. So there will be a mix up of this that we'll be doing. So if you go to next slide, Praveen, that that's where we started to see that the impact that it can do. HVAC equipment are the one of the most important part of the building system. So they are the biggest contributor of energy consumption, also the carbon footprint. So we decided to build a system which helps to optimize the HVAC equipment sizing, design, reduce the energy consumption, but also make sure that thermal comfort is maintained. And with this as a perspective, we went back to our whiteboard. We tried to figure out, okay, what are the solutions that are there, where the existing technology can be used. We wanted to do it in a very quick time of period, because if we keep just spending years and years, and then if users are not able to use the solution, what is the value of that, right? So we reached to Ian. We said, like, Ian, this is the thing that we have. He generously provided help and mentoring, and we started working with Autodesk team, use a lot of Autodesk component, and then build a connected workflow, which now is as a building AI. I'm thankful to my early adopter and the people. So we actually did a early technology access release in IBPSA event. Uh, and we also released this in AHR Expo, where a lot of early user interacted with us, shared their insight, shared their feedback. And through that journey, we have fine-tuned our models. And these are the set of users. I think some of you have already joined in this call. Thank you all for openly sharing your data, sharing your challenges, and basically helping us to conceptualize the solutions which meets actual user problem. So definitely this is a co-creation that has happened with our users. So this is really great that the product meets what customers were looking for. So if you go to next slide, Praveen. uh, this is the now building AI in which you are able to do a load calculation, energy simulations using small bits of agentic AI workflows. So uh, it is still powered by Energy Plus engines. That means your solutions are accurate. Your load calculations are accurate. We are following a physics part. So it is not that it is just a data driven, because we still feel the space of building physics is very complicated. There's one parameter can make a big difference. So to build a data driven model for this, it will take a lot of time. But the agentic AI is here to help us to remove the blockers in terms of amount of effort that we need to do in creating a energy model. And we are hosting this on Autodesk Platform Services, AWS, So you will see a lot of those being integrated in building this application. And if you just go one slide back, Praveen. So we are also using AEC data model to continuously update your Revit model. So when you bring up the a PDF or drawing, we convert that into a BIM model. But if you bring a Revit model, that itself we can start editing. And the editing I mean to say is like we start to add information of schedules, materials, construction set, and they are synced up all the time with your original design. So that helps you to keep up the space. And if you go to next slide, Praveen, you will see that right now the key functionality that we are bringing out is basically heating and cooling load calculation. The second part is the energy modeling aspect, where we are able to do Volier uh, energy analysis. And through our another application, that is autonomous HVAC CFD, you can also do ASHRAE 55 occupant thermal comfort analysis. You can also do indoor air quality analysis, which is a high fidelity simulations for your building space. Going forward, we look forward to integrate Autodesk insights and then try to also bring up the value of life cycle cost analysis, embedded carbon, those aspects. And then we will do a whole building performance simulations where you can simulate daylights, moisture and mold problems, noise. And basically, the idea is to make our indoor environment pleasant and delightful to the occupant. So that's the goal that we have taken for ourselves. Uh, Praveen, next slide. Yeah. So in building AI, we will do a quick demo in just a couple of slides. You will see that what we have done is we have built a small workflows to do certain tasks. So for example, when we started to talk to our client, they said that generally the design is coming through drawings or PDF files. So we have built a certain tool, agents, to get your data from PDF to a BIM model. We also build AI models to create a simulation data. We have created agents for doing reports. So for example, you want to do ASHRAE 90.1, ASHRAE 183. So that kind of different agents that are built. And there are agents also to specify your materials, construction set. And this is a beginning where we have started building those. And as time progresses, those will more and more agents that will start to come in, which helps you in a broad level of thing. And we believe there is a huge role for HVAC and energy modeling community here. We are looking this as a human in loop application. We do not think that this is going to be a single click thing where it will do everything, and we don't want that as a part. We are looking it to be part of a tool of every professional in this industry. That's the vision and idea that we have for the product. So if you go to next slide. Yeah. So here you will see that we have built a functionality which are the one of the most important one. Like how do I take a drawings to BIM? How do I do a load calculation? How do I do a project management? How do I do a code compliance? So these are some of the key functionality that we have developed. And as time progress, we will see more and more additional functionalities that we will develop in this space. So in building AI, you can do a very detailed analysis in terms of the site locations, building types, different standards. You can also do a very detailed load reduction exercise to optimize your building envelopes. We provide a ways to define the schedules for each and everything. And we also give standard templates to save the time. So again, we are leveraging Revit here for accessing the standard schedules and schemes, where you can provide for people, lighting, power, everything that you can come in. And then the most important thing is the HVAC system design. So that's where you can create a range of air systems, plants, and once you have combined this in a quick time, you can then start to get a load report, whole energy report. And there are a report GPT kind of tool, which basically goes through your data and quickly build the reports as per your types. We will be also providing more detailed things such as PID diagrams or the ducting inputs and other things. We are also doing a connection with Tandem, where you will able to take a benefit of digital delivery, where the operations is now becoming a most important part. So we are also doing a work on this, and there is already something available right now from our team. So once we did this, Praveen, next. Yeah. So once we start to see this thing, we realize that Revit is definitely a good way to bring up the design, and that is a helpful. But a lot of our customer are there who had architectural drawings. So what we have done is we have built a data connector for AutoCAD architecture, where it goes and bring up the AutoCAD architecture design and then run a Revit system analysis, the Revit design automation to build a complete BIM model. And so from that point onward, you can start to do that. We also have developed a tool to extract the layouts from PDF. And then we have also done a floor space JSON integration. So if you do not have anything, you just want to start sketching and try something, there is a tool within the app to sketch your design and build a model. So you will see some of these demos where we will show you how you can use a PDF to BIM, and you can quickly create your design and start simulating them. And this is a little bit experimental because everyone know that this is not an easy problem to solve, but we understand that this is one of the most pressing need. There's a lot of hours that are being spent, so we decided to go ahead and build this tool. Ravi? So a quick demo of this PDF to BIM agent. So it's a simple tool where you basically bring up the PDF design, and there are certain inputs that from which you can clean the design by some part. And once you have that, you run the AI detection tool, which quickly find out the door, windows, and things. And there could be a time where it may not able to do that, and then there is a manual input that you can add. And it just takes typically 2 to 3 minutes to generate this accurate design for an energy model. And the nice thing is that you don't need to bother about how do I find out the edges and things, and then that's it. You have this, you can go to floor space JSON, you have a editable floor plan in a way. And if you want to make some change, you can do that. Otherwise, now this is straight goes to the energy modeling cycle or the load calculation cycle that you want to do for this project. So there's a next, we have worked also on we also worked on a Revit connectivity, because Revit has been the now go-to tool. A lot of governments are insisting that we use a BIM in the process. So more and more Revit designs are coming, but they are created more from construction point of view, and what we need for energy modeling, there is always a difference. And Ian and his team has done a really fantastic job of simplifying this design as per your requirement from energy modeling perspective, closing the gaps, closing the openings, and extract an energy model that can be used. So we have built that. And we are also doing a bidirectional connectivity, where basically you also will able to write the output simulation data back to Revit. Output there could be changes you might have done in materials, schedules, construction state. You can also write back into Revit so that you can continue working on that project that you have. And so Praveen, I think there is a demo somewhere else, but we'll see in a bigger part of it. So in building an assistant, basically it's an assistant available to you, where you might have any question in your mind, like where can you show me certain windows, can you show me certain floors, can you find out the volume, can you find out the area, those kind of thing that it is able to do. And so there is a AEC data model that is running at a back to answer your queries. And this is just going to go bigger and bigger. There will be a lot more functionality and feature that we are doing, and it relies on open AI's intelligent capabilities to process your data. And we will see more magical experiences as time progress, and the more and more feedback we receive from you of what your particular workflows that you will try to run. Next. Yeah, so this is a good demo of what AI assistants can do for you. So you can bring up the design, and then you start to say, okay, can you like show me the or select all the walls on a certain side? Can you select a certain windows or floors? And you can also do a certain application of materials. So that reduces the task which you would have done in general in manual way. It can do a little bit of maths also. You can ask to combine or decombine, that sort of thing. And I think this is like every time we ourselves use, we also start to get surprised the way it works, because what we have done is we are given access to the data, and we have also exposed certain APIs to manipulate that data. So if you look from a software engineering point of view, this is nothing but a extract, transform, and load. So what we call as ETL cycle, and that we are able to do using a building AI assistant. So uh, earlier we would have to require to write software features and things which you don't. You just think of something, you write in a text form, and it would go ahead and change that. And especially with the new generation who are now so used to with different AI tools, I think they would able to use it a lot. And I would suggest you to try this out. I'm very sure that you yourself will find some good surprises, positive surprises in terms of that what it can do. And we are open to a feedback on, because there could be something which you may not able to do, and we will try to include that. uh, and this is many a times time saving. It also reduces your mental load to remember things. You can always ask it. It works as assistance to you, and helps in solving challenge in terms of mapping a data and things, because it has access to a large set of information within your model. And so here you can just go ahead and create a construction set. You can create materials. uh, Rohit or Praveen, you would like to add something? Please go ahead.
Yeah, so here we are, taking user input in terms of Excel file or the PDF file, so that he can easily create a construction set, provided by architect. No need to manually create all the data again in the software. And yeah, that's it. That's the steps to make it easy, and a user can create the construction set on the go, and that is the demo. Yeah.
Yeah, so I think it saves your time. It saves it also is in a context, so it knows where your project is, what's your location. Based on your location and weather part, it start to suggest you the material. So that it has a certain inbuilt intelligence to do this task. Yeah. Next. Yeah. So there are more agents and more things as you start to use a building AI assistant. I think you would experience those. In a product, you will see that we support a lot of HVAC systems which are important for your projects. We support different AHUs, different terminal units, plants that can be very easily accessed from our application. We have also created a data hub, because there are a lot of HVAC consulting organization may not have ability to open all these formats, so or to share or save these files. So we have built a data hub in which you can save your files, you can share that with your customer colleagues. There is a version control available. So if you by mistake add another file, it will create a new version for that. So there's an inbuilt version control. And if even if you delete, there is a backup available in our data hub, and you can open hundreds of file that is coming to your from your customers. And then we have a report assistance, which helps you to do, as I said, load and energy reports. You can also add your own branding, your own logo, your own color scheme. You can tell it to remove certain tables, change the units. So you don't need to all the time click certain things and generate the reports. There is a simple English language way to communicate the what type of output that you want. Praveen? So I think this is a broad workflow demonstration in which we will see end to end how projects are being done. Praveen, would you like to walk through this?
Yeah, am I audible now?
Yeah.
Yeah. So this workflow is particularly, showing the demonstration of how you import the 3D model. I guess there is some, yeah. So you have imported the 3D model from Revit, like you have the building configurator. So you can see the Revit model with all the details, tree structures, and all part of components. Everything is imported here. So you can see the model tree here. Okay. And the next stage, like you can visualize and select elements and filter based on the like using the model tree. Okay. So you can see the wall and assign materials through UI as well as the tabular way as well. So here you can see what materials has been assigned and change them depending on your requirement. And the same thing goes, and I'll just slightly go further. Yes. So next, the space type. So depending on the space names created in the model, then the app automatically assigns the space type based on the location and code requirements. Okay. So depending on the space type, then the associated internal loads and schedules will be assigned to them. Now you're creating zones. So for condition space, and then those options are available. You can group the, for example, the peripheral zones and the circumferential spaces and the core spaces separately. So based on your design requirement, you can create separate zones. So once this zoning is created, then the next step is to go for the HVAC system configuration. So after assigning the HVAC system configuration, then in run load simulation, you are setting up the what simulations you are looking for. Like you can select a ideal air load systems also, other than the standard templates that we provide. The load simulation and energy simulation runs on the cloud, and you can visualize the detailed results. So this shows the load calculation is as well as the energy yearly energy analysis that can also be accessed here. Okay,
Yeah.
then yeah.
Please go ahead. Yeah.
Yeah. So this is the report assistant, which even Sandeep mentioned about. So here in your natural language, you can interact and give some prompts to extract information. So once the simulation is completed, you can extract the load calculation report and the SQL file that will be passed on to this module, and then it can generate the Word file load calculation report, standard load calculation report, which has all the detailed information about the project, weather data, peak loads, both cooling and heating. So space, both zone wise and space wise. So all those summary is included. So it complies with ASHRAE 183 and ASHRAE 62.1. So you can also generate or analyze, like we should generate visuals and graphs to analyze the results. So this is a easier way to, SQL data has too many informations for each and every space and thing. So now
Right.
you've got a tool to readily extract what you exactly looking for. Yeah.
And
Sandeep,
if you have a financial or cost data, that also can be integrated. You can add it, or if it is already existing, your model is able to find out that and start integrating and give you the cost analysis part also,
yes.
right? So we can go to in the next part of it. And so this is what we already have. Right now, you are getting the ability to bring your AutoCAD architecture drawings. We take that and then able to create a BIM models. That definitely saves a lot of time. Uh, Second is definitely if you already have a Revit the model, Revit design. Now, because this building AI runs from a different software, sorry, different computers, so you can access it from anywhere. The whole team can access this part, because that's one of the enabler that we wanted to build. You can always now import from PDF file also, create your energy model, the BIM models. And if you don't have any of that, you can use our flow space JSON. I've not included the demo for the sake of time, where you can just click and create your this point. Going forward, you will see we will be also supporting AutoCAD Vanilla, which is also a lot of user use. We'll be supporting IFC import, GBXML import. Um, this is we already able to do that internally, but we are still testing and fine tuning that, and so that will come. And Forma will be also given for a early stage evaluation, and then later we will be doing a SketchUp, Rhino, and ArchiCAD integration, so that you are able to bring up the data from wide source of possible building design. If you go to next, we are also working on HVAC configurator. We already have a certain set of pre-baked systems, but we are doing a complete HVAC system modeler where you can define your own HVAC system. You can do your own connection and own things. And I think this is going to be really first of kind, where a very comprehensive HVAC system that can be created as per your requirement. And this is a very mammoth task that we are taken up, and then that we are able to run on for load and energy, and then you can use it for a lot of your projects. So this is the thing you should stay tuned for. Hopefully by next quarter we should be able to release that. Next. As we start to work in this space, you realize that that definitely PDF to BIM is one of the important part, and we are able to build this HVAC system is a good, but the real thing and the real value that comes is in an operational part, where we are able to map all that from start to end, and able to leverage the Tandem's capability to help you in terms of operational efficiencies, help you to do fault finding and other part of it. So we are also working on that part, where you not just give the output of your design in terms of PDF, but hand over a Tandem single click a digital twin, and that produces a lot of delight for the end users, because they can see everything map, all the data that you have got from simulation, your systems, their uh, data sheets, all will be in a one place. And this also is of a great value to a lot of companies. So we are doing some work in this space already. If you go to next slide. So this is the part where I will give hand over to Rohit. So it is a very interesting case study that we did for a process industry, and where our customer were able to see the value of building as ability to model even the factory kind of setup, and give a great insight. So Rohit.
Yeah, thank you, Sandeep. So let me take you inside a real process plant where we worked with one of our customer. It's a winery, and can you go to the next slide, Praveen? So few facility details are like it is located in Pune. It's a warm, humid climate zone. We use different construction site as per the ASHRAE standard space detail. It's a small factory around 3,000 to 4,000 square feet. And Praveen, can you go to the next slide? Yeah. They had just, installed the brand new fermentation tank, sized their chiller plant by the handbook. And on paper, everything looks perfect. But once the operation began, all tank consistently failed to stay within the temperature threshold. Production was at the risk, and no one can explain why system wasn't performing. So when we analyze the exact issue, we took the digital twin approach, where first we want to model the exact scenario and simulate, and then take the appropriate action and suggest the scenarios to the facility manager. Praveen, can you go to the next slide? So what we did is we created a virtual twin using Building AI platform. We model everything as per the facility details, and created the HVAC system, created all the chillers, pumps, tanks, tracked all the critical variables like chill water temperature, pump flow, chiller KV. And finally, we are able to visualize the current operational scenario in the Tandem. And we are able to see the hidden drivers. So what was the revealing is the ambient heat and solar gains was really underestimated, even though the design was created as per the handbook. So what we did is we created multiple scenarios, what to be changed so that process conditions are met. So we found different issues, like instead of immediately upgrading the chillers, we have added we have suggested multiple changes in the HVAC systems. One of this is like adding a particular insulation to the fermentation tank, changing few chiller parameters. And so with no capex increase, like as a zero capex increase, we are able to play the scenarios digitally in our Buildings AI platform. And once the everything is under control, the process conditions are met, because to get the perfect wine, the fermentation tank needs to be at less than 4 degrees Celsius. And with our Buildings AI simulation scenarios, we are able to replicate them virtually. Then we suggested those changes to the building owner, implemented those changes, and we are able to match the process condition 100% of the time. As we are able to and the byproduct was we are able to reduce the energy consumption. So if you, Praveen, go to the next slide. So these are the outcome. The main issue is fermentation threshold needs to be met all of the time. Otherwise, the batch size of that particular wine is wasted. So that was the achievement. And yeah, and we de-risked the entire process using the digital factory simulation using Buildings AI.
Right. I think this was a fantastic story where we could see the utilization of simulation into the building operations, whether it be a factory or whether it be it's data centers or buildings and every place. So we have a more case studies, but we just decided to highlight this one because which was very, very interesting and different. Next slide. I think we are short of time. Oh, okay. So this is an important one. So there is a trial version which is accessible to everyone. You can run different simulations. It has you can do a pretty large simulation at a time, and it has data storage and other functionality that are available. We also are launching our subscription offer here of $2,500 per year access to the organizations. and where you can do really a lot of simulations and do your project within a time. And we are also coming with the enterprise licensing, where if you have a lot more user, we can give you a discount and make sure the whole organization is able to use our application. Next.
Yeah, so we have some exclusive offer today. So sign up today and you'll get, instead of regular 15 days, you'll get 2 months of free trial period. So exclusively for the launch event attendees today. So that's the thing. Yeah.
Right.
Okay, so with that, I guess we are at the end of the session. So now thanks, Sandeep, Ian, and Rohit for sharing your valuable insights and walkthrough of the application. And we can, take the
Projects questions are there. I think
questions. Yes.
where do we start? Okay.
Sandeep, you're able to see the questions?
Yeah, I'm able to see the
Okay.
question. Yeah.
So, can I
okay.
interrupt here?
Sure.
Yeah, so this is interesting one from Octavian. Thanks for your insights into this. So what you are asking is basically AI agents which are trained on energy conservation measures. So right now we are doing it sort of in a human in loop way where you can actually upload your mandates into the data hub. Our LLM based AI assistant can access those documents. It also has ASHRAE 90.1 in the backend. So it has those regulations based on climate zone, and it can come up with alternative scenarios or sensitivity simulations. Let's say 4 or 5 such scenarios based on your target criterias. But you would have to right now run them manually, run those fours and see the comparative and come up with your target, like whether it is meeting your target or not. In future, what we also plan to do is, let's say all these scenarios are run in the buildings AI. Those will be available. The results will be available in the data hub. Your current model can be trained with these, and also you can actually directly get insights without running the actual simulation. So you can directly get some insights into what sort of wall to window ratios, what sort of materials you can directly use to meet those mandates.
Okay. Okay. Thanks, Swapnil, for answering that, and thanks, Octavian, for putting the questions. Yes. So, do we have any other questions? Okay, so yeah, the recordings of the webinar, yes, it will be available to you. We'll email you shortly. We'll just edit and process the video and then be sharing those through emails. Okay, from here, what's next is you can right away sign up today for the trial, or you can schedule a call with our product expert, Swapnil, and then we'll guide you through, we'll understand your requirements and we'll guide you what should be the next steps. Things. Can this be used by non-energy modelers as well? The learning curve set. Yes,
Yeah.
Octavian,
So,
yes. Yeah, Swapnil.
Praveen, can I take that? Yeah.
Yeah, sure.
So, Octavian, our whole philosophy behind designing this software is basically a classified layered approach, where we have for the purist or the experts who want to customize the whole model, we have the entire workflow for them. We have 4 types of inputs, right from like sketching your own floor plan from drawings and also directly from Revit or from AutoCAD architecture. So you have automated workflow, which are for users who don't want to spend much time into customizing or doing all the process manually. They can do it through LLM, through AI assistant. And for the purist, we have like the entire workflow, which starts from retracing your floor plan, coming up with a customized each floor, different design, building your entire building, all floor, different layouts, coming up with a detailed model, using the UI steps, customizing your own HVAC systems after you get the initial results. And you can actually do all the details with the entire Energy Plus, full Energy Plus report in the backend. So that path is also there. And for which needs some learning curve. And for users who want very simple workflow, we have the entire workflow based on LLM, which you can just use our AI assistant to quickly get results in the viewer. And that takes few minutes. So we have for all different users, we have the entire workflow which can be used as per their requirement.
I think there is a question, how does AI improve decision making in building AI compared to conventional simulation engines? Swapnil, you would like to take?
No, where is the question actually? I'm not able to see.
Yeah,
There is a Q&A session.
Oh, okay. Sorry.
So AI helps in various ways, because what we have is the various iterations of your data, simulation data with the engine, and then it can, based on that, also suggest you how you are improving your design. It can also understand the context, and based on that context, like where is your building, what type of usage of your building, it can also suggest you the right materials, right construction sets, things. Uh, there are other small things like when you are putting up a certain schedules or certain loads, it can understand the other parameter, and if you are making a mistake, it also tells you or forewarns you that looks like this was supposed to be this and you are putting up this. So that also, these are very small decisions, but they also can make a big difference in a final outcome. So various ways this helps you into getting a right right outcome. I think Tanvir has asked, what is the engine used for energy calculation and methods for loads heat balance? So yes, so we are using a heat balance method from Energy Plus, and Swapnil, you would like to expand something on this, or?
Yeah, so we are using Energy Plus as a backend engine, and basically it is like the process that we are automated. It starts with recognizing space types from Revit or the input model, and there are smart defaults which populate your space types. All your load inputs, your schedules, your occupancy are basically, there are smart defaults which are 183 ASHRAE 183 compliant. User can change those as required, but like the baseline simulation is ready with those defaults, and you can start using Energy Plus in the backend.
I think we can take a last question, Swapnil. How close are the results compared to actual building performance in validation studies? Any insight you can share about the validation studies?
Right. So currently we are using this for selective, like early users, and we have used this for large around 20 floor building models also, and we are in process of publishing those validation studies. Now, I would say in terms of the baseline individual simulation results, we are around, I think, 90-95% close, because the Energy Plus engine is itself validated. We are if the space types are well defined in the input CAD or the input Revit model, we are around 90-95% close to what other commercial tools based on Energy Plus are showing results. We are also in process of validating the ASHRAE 140, but that will take some time as we develop the tool further.
Right. I think we're close to a time. So what we will do, there are a lot of questions still remain unanswered. We will email you the answers, and I think Praveen will also publish a follow-up blog in which this recording will be available, and also answer to the questions which we answered here and some which we couldn't answer. So that will be shared to all the participants. Thank you all for participating into this release. Thank you, Ian, for taking time out and sharing your insight and wisdom.
Thank you.
Thanks.
Thank you.
Thank you all. We look forward to use our application very soon. Thank you.
Thank you. Bye.